Hello everyone. Today, we're going to dive into the gas laws. These are important rules in chemistry that explains how gases act in different situations. We'll cover Boyle's laws, Charles' law, Gay-Lussac's laws, Avogadro's laws, and the combined gas laws. We'll break down each law, look at their equations, and see how they affect our everyday lives. Let's start with the Boyle's laws.
Boyle's Law. Robert Boyle first came up with Boyle's Law in the 60s. This law says that if you keep the temperature of a gas the same, its pressure and volume are opposites. When one goes up, the other goes down. We can write this as a formula. P1B1 equals P2B2. Here, P represents pressure and B represents volume. This law helps us understand how we breathe. When we inhale, our diaphragm makes our lungs bigger. This makes the pressure inside our lungs lower, so air rushes in. When we exhale, our lungs get smaller. The pressure goes up and air is pushed out. Another example is a syringe. Pulling back the plunger makes the inside of the syringe bigger, which lowers the pressure. This lets liquid flow in. Boyle's law explains why these things happen.
Charles' Law. Jacques Charles came up with Charles' Law around 1780. This law says that if you keep the pressure of a gas the same, its volume changes in the same way as its temperature. When the temperature goes up, the gas spreads out, and when it goes down, the gas shrinks. We can write this as the example below. Here V represent volume and T represent temperature in Kelvin. Hot air balloons are a great example of Charles' law in action. Heating the air inside the balloon makes it expand, which makes the balloon less dense than the surrounding air, causing it to rise. When the air cools down, the balloon shrinks and descends. Another example is car tires in cold weather. The cold temperature makes the air inside the tires shrink, making them look underinflated. Charles' law explains why this happens.
Gay-Lussac's law. Joseph Gay-Lussac discovered Gay-Lussac's law in 1808. This law states that if you keep the volume of a gas the same, its pressure changes directly with its temperature. When the temperature goes up, the pressure also goes up. We can write this as P1 over T1 equals P2 over T2. Here, P represents pressure and T represents temperature in Kelvin. A pressure cooker is a common example of Gay-Lussac's law. As the liquid inside heats up, the pressure builds up, which cooks food faster. Aerosol cans are another example. When exposed to high heat, the gas inside expands, increasing the pressure. This can potentially cause the can to explode. Gay-Lussac's law explains why this happens.
Combined gas law and ideal gas law. The combined gas law brings together Boyle's law, Charles, and Gay-Lussac's laws. It shows how the pressure, volume, and temperature of a gas are related when the amount of gas stays the same. P1B1 over T1 equals P2B2 over T2. This law explains how these factors change together in different situations like weather changes or tire pressure fluctuations. The ideal gas law represented as PB equals nRT. Expands on this by including the member of gas molecule. Here R is the gas constant. The ideal gas law is widely used in scientific and industrial fields, such as calculating gas behavior in engines, predicting weather, and designing refrigeration systems.
In summary, the gas law, Boyle's law, Charles' law, Gay-Lussac's law, Avogadro's law, and the combined gas law provide the theoretical framework to understand the behavior of gases under various conditions. The gas laws are essential to many everyday activities, from simple breathing to complex tasks like diving and weather forecasting. By understanding these laws, we can appreciate the practical applications of chemistry in our daily lives. Thank you for watching, and we hope this presentation has enhanced your knowledge of the gas laws and their relevance to our daily lives.